Hello everyone, my name is Penn and I use they them pronouns. I'm a chemistry professor at the University of Minnesota on the Twin Cities campus. I'm also the director of undergraduate studies in the chemistry program. I parent a teen, I'm also a bike racer, and this is Bella. And Savvy. And last but not least, this is Dubby. Before I start to tell you about our research program, I want to take a moment to acknowledge the land on which we learn, do research, and teach. The University of Minnesota Twin Cities is located on traditional, ancestral, and contemporary lands of Indigenous people. The university resides on Dakota land ceded in the treaties of 1837 and 1851. The Penn Research Group has many graduate students and undergraduate students working in three primary areas. The first primary area is in material synthesis. We make nanoparticles with controlled size, microstructure, and morphology for use in experiments that are meant to simulate what happens to materials in the environment, and also for use in technologies like solar energy conversion. Some of our goals include making materials using green methods so that our materials are benign by design and then also generate less toxic waste. Another area in which we do research is environmental chemistry, where we look at how pollutants degrade in environmental systems, and we also look at the geochemical cycling of the elements. The final area that we spend a lot of time is looking at the properties of nanoparticles, whether they are natural nanoparticles that we collect from the environment or nanoparticles that we make in our lab. We specifically look at how nanoparticles grow, how they transform, how they aggregate, and also how they react in environmental systems. An important method that we use in the Penn Research Group is microscopy. We use both light microscopy and also electron microscopy. What you're looking at here are 6 images collected using electron microscopy. We look at titanium dioxide, we look at iron oxides, we look at zeolites. We also look at dispersions, like crude oil dispersed in water. Such results are important when you think about oil spills in the environment. Iron oxides are important in environmental systems. For example, if you ever see a stream where you see strong red color or orangish yellow colored solids, that color often comes from iron oxide nanoparticles that have formed naturally in that system. The zeolites are important because we can use those to separate molecules according to their molecular size or shape, and we can also use those materials in catalysis in order to make new molecules with new function. Finally, a really important part of our research group is education and outreach. And here I've shown a whole bunch of images from our various outreach activities. This image here, camera phone colorimetry, lets people use their phones to take photos of solutions that contain colored analytes, and then you can analyze those solutions and determine their concentration to 3 significant figures. It's a pretty impressive way to use your phone to do neat science. We've applied this to determining the concentration of gold nanoparticles in a suspension, iron oxide nanoparticles in a suspension, the concentration of Gatorade and other drink mixes, and even the concentration of proteins. We've done fun science with middle school students, and also we collaborate with a group called Minnesota Queer Science, which brings queer high school students onto campus for an entire day of science with queer grad students, postdocs, staff, and faculty. And I gotta say, we have a pretty excellent time. Last but not least, I'll just close with Happy Pride. I hope you've enjoyed watching, and don't hesitate to contact me if you have questions.